Okay, so here's what a lot of people did in second period that ended up making it wrong. So they graphed the 2 points. Some of them obviously graphed the points wrong. Okay, that's not ideal, but it's okay. -3, 5, 7, 2. Okay, but then they connected the dots whichever way they wanted. That's a problem. You have to start at which point. The initial is -3, 5, and then you have to connect to 7, 2. So remember, the order matters because your X and Y is going to come out different based on where you start. So for vector U, I'm going to start here. I'm going to count over 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Then down 1, 2, 3. So 10, 3. Is that right? 10. -3. Good. Okay, then from there, I want the magnitude. Do you remember how to do it? What do? Okay, so it'd be 10 squared plus 3 squared, then square root. So 10 squared is 100, 3 squared is 9. What's 100 plus 9? So root 109. Put it in the first blank. And then really, I had intended for this to be an equivalent because we're going to round it to 1 decimal. So in your calculator, what is the square root of 109? So we'll do 1 decimal, so 10 points. Okay, second part of the question, we want the reference angle. Which of the trig functions do I use in the unit circle thing? In vectors? Tan? Tan equals y over x, which means that I'm going to end up inverse tanning on the y over x, which are what numbers for this question? 3 over 10. Very good. Okay, so 3 over 10. So go ahead and do that. We're going to round to a whole number just like we've been doing. What is second tan of 3 over 10? Okay, it's 16.69, which we're going to round to 17. Okay, then for the last part, this is tricky. It says finds the direction of the vector. What quadrant is my vector in? 1. But if it was centered at the origin, would it still be in quadrant 1? It's going to be in quadrant 4. So I'm going to redraw it. 10, -3 should be here, which means that this is really a quadrant 4 vector. So remember, you can graph it wherever in order to count the X and the Y, but when you're doing direction, it has to be recentered. That's why you draw it on Delta Math, and then you click and drag it back to the center. So what is my quadrant 4 formula?
60.
360 minus. Quadrant 4 is 360 minus 17. Then what's my final direction?
343.
43. Yeah. Okay, do we feel like we could do that?
Yeah.
Okay. And actually, I probably should have started with this, but like, can we fill in? You're going to get to use your formula chart. So you'll see you have the unit circle on one side. We'll do that at the end since you've been doing that longer. We're going to do the vector side. Okay. So your component vector AB, your A is your horizontal, B is your vertical, can also be written as AI plus BJ. Okay, and remember, we just learned this second form last class. Okay, the way that you know this is a vector are the pointy brackets. The way you know that this is a vector is the little symbol, the little hats on top of the I and the J. So this is called component form, and this is called unit vector form, or standard form is the same thing, if you want to put that. Okay, the magnitude of a vector, we just did it, is double bars for the symbol, and it's a squared plus b squared square root. A squared plus B squared square root. The symbol to show that you're finding magnitude is like double absolute value bars almost. Okay, the reference angle measures the shortest distance from the vector to the x-axis, but remember that the reference angle is measured within the triangle. How do I find that? What's the formula? Tan theta equals
X, Y,
y over x. And then remember that you're gonna use inverse tan on y over x to give you your reference equal. Okay, so this is reference angle. Okay, then after you find your reference angle, direction is measured from the positive x-axis counterclockwise around the circle. So if you know your theta, let's just draw the little chart because it won't be on the board when you take your test. Quadrant 1, what do I do to theta? Keep it the same. Quadrant 2,
180.
minus from 180. Quadrant 3 is 180 plus theta, and then 360 minus theta. Okay. So once you have that written down, we'll come back and fill in the bottom of this when we do a word problem. But I want to work maybe 1 or 2 more of the easier vector problems before we get to that. So if you'll turn the page to number 4 on your review. Okay, it gives you 3 vectors. It says, consider the vectors given below. P is 2, -7, U 5, -4, etc. Then part A says, rewrite each vector in terms of the unit vectors. Okay, this should be the very easiest thing on your test. If P is 2, -7, then P is also 2I minus 7J. Do you remember that? Okay, you're literally just taking the horizontal and vertical components, putting an I with the first one, a J with the second one. Can you finish the rest of those, please? Give you a minute to do that. So if U is 5, -4, then it could also be written as 5I minus 4J. Can someone read me their answer for A when they have it? Perfect.
Great job,
Okay.
guys, great job.
Very good. Then out of the examples, we're gonna do the middle ones, we're gonna do C. So it says P minus double vector U. So I'm gonna put P minus 2U. I'm gonna put P in this spot. I'm gonna put U in this spot. Now, you have a choice. If you wanna do the IJ version of the vector, you can. But I'm gonna use the pointy brackets just because it's a little bit less writing. So my vector P was what coordinates? 2, -7, and then minus 2U. My U vector is 5, -4. What should I do first? Should I subtract or should I multiply? Multiply is correct. So are we just gonna times the 2 in? You're gonna take the entire -2 and multiply it in. Now, quick question, what will happen to vector P if there's nothing to multiply in? Just keep it the same. So my 2, -7 is still 2, -7. But my second vector is a -2 multiplied by 5, what is that now? -10, and then what about -2 and -4? 8. +8. And now your symbol in the middle is addition. Because you worked that negative into the X and the Y, so now you're just adding. How do I add vectors? Both of the X's together, both of the Y's together. So what will my X coordinate be if it's a 2 and a -10? Perfect, and then what about -7 and 8? 1. Okay, if you wanna put a little note to yourself here, remember PEMDAS, you multiply first, add second. Okay, so multiply first, add second. Okay, if you are describing the changes to a vector, take a look at letter F. What would happen to any vector if I did half of the vector, graphically speaking? So-
It would
Okay, what?
compress,
Okay, compress, but make it easy. It would get
small.
shorter. Okay, so I'm gonna put half P is shorter. Now, not only is it shorter, it's exactly half the original length, right? Second question is about the direction. If I just cut the vector in half, should it point the same way or the opposite way? Same. So now let me show you an example of that. Okay, so let's say this is P. Then this would be half P. And if you remember from that homework where we were like, kind of like shrinking the vector or doubling it or whatever based on the length. So P and half P are pointed the same direction. Okay, now look at G. I have P and -3P. First question, will -3P be longer or shorter than original vector P? It is gonna be longer. How much longer? 3 times longer. What does the negative change? The direction it points. Very good. So it's gonna point opposite direction. So if this is my vector P still, kind of sketch it about the same. Then if you times it by a -3, it's gonna be 3 times as long, but point in the reverse direction. So your -3P would be, oh, that's maybe too long, but. That's what -3P would look like. Because if my X and Y are positive and I turn to both negative, well, then now it's going that way. And it should be 3 times as long. Get it? Okay, last question we're gonna do for right now is one of the word problems on the next page. We're gonna do number 7. Okay, so you have one word problem, number 7 that says an airplane is traveling 350 miles per hour on the direction of south 25 west. So let's start with the component vector. How fast is the airplane going?
350 miles.
That goes in the front, 350 cosine an angle, and then 350 sine angle. Okay, because remember, 350 is the strength of that force or the magnitude, how long the arrow would be. Okay, then the direction says south 25 west. So on your little thing, I gave you a north, south, east, west. So let's come over here for a second. If I want to do south 25 west, perfectly south is the same as what direction in degrees? Good. Now, while we're here, can we fill in the other main ones? What would east be? I'm gonna put 0, but 360 is also right. And then what would north be? 90. And then what would west be if I go halfway around the circle? 180. Okay, so now let's go back to our problem. We want south 25 west. So I'm gonna start pointed south. And then I'm gonna tilt 25 degrees west. Should I add that or subtract it from the 270?
Subtract.
You should subtract. Very good. So if I go 25 degrees this way, that would put me here. And maybe don't draw this on yours just because you get to use it on your test. You don't want a bunch of crap all over it. Okay, but what would my direction be if I have to measure this way? How many degrees? 245. Plug it into your blank on your review. So it'd be 350 cosine 245 and sine 245. Okay, now let's do the wind. How fast is the wind blowing?
40.
40. So I'm gonna put W for wind equals 40 cosine something and 40 sine something. And then to find that angle, if it's south 32 east, go back to your compass. Okay, I'm gonna draw it on here this time since we already labeled everything. What was south? 270. But this time I want to tilt 32 degrees east is this way. Do I add it or subtract it? Add it, because remember, when I measure, I have to start here. So I'm gonna pass 270 to go 32 more. So what direction would that be for my plane? 302, very good. Now, the next step says to draw a vector diagram. I'm gonna make that step optional because I didn't put it on your test. You should be able to do it, okay, but I made that optional here. So for the next section, we're gonna write the component vector, taking into account the airplane and the wind. That means we're going to add. And in the calculator, when you add, remember, you're gonna put the two X's together and then the two Y's together. We're gonna round to 1 decimal. So my new vector is gonna be, I'll do the X if you guys maybe wanna do the Y's. 350 cosine 245 plus 40 cosine 302. So I got negative 126.7 for the X. Okay, if you guys will find the Y for me.
Negative 351.
Negative 351. No decimal after that?
It's 0.129.
Okay, so 0.1. All right, then from there, you're asked to find the magnitude. Remember that magnitude is how fast the plane would actually end up going. You already know the formula for it though. It's this squared plus this squared. Take the square root. Do I care about the negatives? No, so 126.7 squared. 351.1 squared. And then square root. So I got 373.3 miles per hour. And so if my plane is trying to go 350 and its actual speed ends up being 373, that means that the wind is working against it or helping it? Helping it. Okay, part E, I want the reference angle. Inverse tan what? Give me the numbers. Over 0.7, very good. Remember, that's called your reference angle. So go ahead and find that. We're gonna round to the nearest whole degree here. Did you all get 70.1? We're gonna round that to 70. Okay, and then for the last part, I want the direction. Then I need to think about what quadrant this would end up being, because remember, I told you that the drawing step is optional. How can I know what quadrant this would end up being in? Whether it's at negative or positive X and Y, right? So if I have a negative 126 and a negative 351, what quadrant would that end up in? 3. So I'm gonna put this as quadrant 3. Because negative X and negative Y. And then what's my formula for quad 3?
Plus
180 plus my theta of 70 gives me 250. Okay, do we have any kind of overall questions? Okay, let's fill in bathroom or actual question.
question.
Okay.
With the add, you add the two like cosines together. And then
Yeah,
two-
so what I did was I did 350 cosine 245 plus 40 cosine 302.
and
So it's this and this for the X, and then you got these two. variables. Okay, real quick, let's just fill in the last little bit of your formula chart here, now that we've done an example. Okay, if your direction is theta. And your length is absolute value V. Then you can break it down into an X and a Y, where your X is gonna be absolute value and then cosine of the theta. And then sine of the theta. Okay. And then rather than writing them separately, I'm just gonna put them together. So that you don't have them individually. Then if you wanna make a note, for word problems, this is the speed right here. Okay, cause how long the vector is would be like how fast the wind's blowing, how fast the plane is going. So I'm gonna put here. Speed for word problems. And then for the theta, I'm gonna put use compass. Okay. So your goal for now is gonna be to work through the front half of the review till you get to the unit circle stuff. Then we'll do only a couple examples in that part, just to make sure you remember it. Okay?
Oh,
Okay.
This, I haven't done the last week before the final one, that one here.
Okay. You can. Huh? What?
I go.
Just take your go pass. What were you gonna say? Yeah. All right, what is? He lost 60.
Don't even follow. I don't want to hear it.
Uh-huh. Yeah. It is, and then I can give you the notes paper if you want it. And then if you want the video, I can give you the video, or if you just want my paper to look at, I can see. Sure, here's that. And then here's that.
Wait, Johnny, can I have?
So the IJ stuff really is only.
Turning the other two.
Yes, but I'll just take them up the same time. I guess I forgot. I never took up.
Okay. Oh, that's good.
So you need it?
I think so.
And I can send you it in the video if you want it. We worked through a lot of that. Do you want it?
Yes.
Okay. We did. It'd be left than 8. Right? Cause you're going left. Well, and then hold on, it's the active.
So you would track with that,
That's
you would divide this.
for your points.
What do you go like that?
It'd be -8, 12.
Miss Johnny, can I have some scratch paper?
Oh, yeah. Will you just make sure if you, oh, you're doing homework, okay.
You would-
Like, that would be-
So it's not-
Negative.
Join it?
14.
Yeah. It's actually this.
Yes.
I forgot what stuff.
Okay, so write it down first. So to get rid of the, what do you think we should get rid of first? Okay, so -4 across. 4 minus 4 is 0, divide the 1.2 out of the front. And what is 0 divided by 1.2? So 0.
And then if the four.
Okay, then at this point, you're gonna go to your unit circle. Cosine is the x or the y. And you want anywhere that your x value is 0 in degrees. So where is your x is 0? So it'll be 90 and 270, set that equal to theta, that should be a theta minus 3. So your first equation will be theta minus 3 is 90. Equals 90, and then theta minus 3 equals 270. And then from there, we'll just add 3 across. Are you on complete solutions? Okay, so do that first. So now you're gonna have 93 for your first answer,
Be like this.
and then 273. Okay, now, may I borrow your pencil? So here's what's gonna end up happening,
Yeah,
is that
that's-
you remember the graph of cosine, we went over it the day before this. Okay, cosine does this. Forever. So how many times is it gonna hit? It'll hit twice in the first cosine, but then it's gonna hit again in the second cosine, and then again, and then again. So the reason we have complete solutions is that you're just gonna list the first 2 answers, and then every time they rewrite,
Oh,
you're
no.
gonna add 360. Because that's how long it takes to go through one full cosine. So this answer, if I add 360, would be this. The graphing was when I was here, but we redid a little bit of it. And your second answer is 270, but every 360 degrees, we're gonna get another one. So you're gonna add 360. So your answer should be 93 plus 360 and comma, and then 273 plus 360. Uh-huh. Now, one more thing. If you get a number like this, where it's between the parentheses, that's gonna change your period, so raise your hand. And I'll help you there. If you get a between parentheses number, raise your hand.
Then I'll-
Or ask. Yeah, 56, right? And then what quadrant would that one be in? 2, so 270, or 274. Or I can't hear what it is. There we go. Yes. Sure. How are you doing over here? I don't know how. Hey, how are you doing over here? In your mouth. Cause, hold on. You're going from -3 up to 9, so it'd be 3 boxes to get to here, and then 9 boxes. So I do the same 9.
What'd you do by this?
That'll sort of adjust your numbers. Uh-huh.
Yes, I'm laughing.
Oh, Lord, are you lost, or how are we doing? I know you've been gone lost.
I watched it. You.
So this is right so far, take the negative off, so let's just do 8 squared plus, here's why. If you're gonna do it correctly, you would have to do -8 squared. Which is annoying then with the negative, because they end up going away in the negative. So it'll be the square root of 208, which comes out to be. So if you're. Yep.
Yeah, I know.
And then for reference angle, inverse tan. So put the tan to the little -1. Of your y over your x. Again, no negatives. So it'd be 12 over 8. So it'll be like this. You'll start off with tan theta equals 12 over 8, but then you're gonna end up inverse tan on both sides to solve. So your theta is gonna be the inverse tan of 12.
So it's not right, and.
Inverse 12 over 8. And then put in your calculator, you get a whole number. It's just second tan. And then 12 divided by 8.
That's the first time Paris is.
56 is right. For these, I have done, for angles, I'm on. But if you're too specific, that's never. So then from there, imagine if this was redrawn to be centered at the origin, which quadrant would it be pointed into? I just split it. Wait, I don't think so. Two, what's your two? Look up there in the corner. It should also be on your sheet. In quadrant 2, you're gonna do 180 minus, here's y. Or do you want me to show you y or not?
Yeah.
Okay, so your thing was to the left, 8 and up 12, right? Like that. So if you turn this into a triangle, was it 56 degrees? Is inside that triangle, but when we measure direction, we have to start from the positive x-axis. So it's all the way across the top. half of
Yeah,
the
I'm
plane.
laughing at y'all.
And I want to shave off 56 degrees. That would give me what's left over.
Wait, we don't keep the negatives for every tan, right?
That's what that little chart does.
It's gonna be like, it's gonna be like my mom, if she can't.
Yes,
I have the number.
okay, hang on a second, did you have a question? You're good, okay, yours is gonna take longer, so just one more second.
Okay. This is my name with my fingers.
Where,
Y'all, I'm like, it's like, behind.
are you just sitting right there? Yeah.
I'm actually not behind. I do know what I'm doing, actually, it's gonna be when I get to the specific question, but
Alright. Okay, so write down your question.
I already got to this.
Oh, perfect, okay, so to get rid of the 5, you're gonna divide by 5.
Okay.
So you have theta plus 100 equals. 325 divided by 5. And then you do the same thing on the other one. Oh, wait, hold on, keep going, minus the 100 across.
So if you don't ask me, like, don't.
Okay. Here we go.
Here we go.
Okay, we're just doing 2 examples off the unit circle part, just to make sure you remember how to do it. So if you'll turn to number 16. Number 16. Okay, if you need help with the other questions in this section, I'd love to help you. I'm just not gonna like teach them, you know? So 16, what do you think you should do first? Huh? Add the 1 is right. Not correct. Well, you could also print while adding 1, but, okay, add the 1 across. So 1 plus 1 is now what? Secant squared theta equals 2. From there, secant is not on your circle, but if you flip it, what does it turn back into? Very good. So I'm gonna put here, flip both sides, which means that my secant squared is gonna go back to a cosine squared. And if I wanna flip this side, I have to also flip 2, but it's not a fraction. What can I put it over? And if I put it over 1, then now when I flip it, that's a 1 over 2. From there, I want to get rid of the squared. How do I do it? Square root. And when I square root both sides, what do I put in the front? Very good. So squared square root cross out, I have cosine theta equals plus or minus the square root of 1 is 1, but the square root of 2 isn't perfect, but I also know I can't leave it on the bottom. So how do I fix this so that when I look on my circle, I'll be able to find it? You put another root 2 on the top and bottom. And remember, the reason that fixes it is 1 times root 2 is root 2. But root 2 times itself becomes a regular 2. And now I can look on my circle for everywhere that cosine would be either plus root 2 over 2 or minus. When you look on your circle, are you looking for this number as an X or a Y? X. Cosine is an X, so will you look on your circle? Where is your X value? Positive root 2 over 2, starting in the first quadrant. Okay, so it is 45, but see your instructions here, we're gonna be in radians for just these 3 questions. So give me 45 degrees, but as a radian. Okay, pi over 4. Okay, go to quadrant 2. Where else do I see plus or minus root 2 over 2? 3 pi over 4, very good. Next one. Yep, and remember, you should never be mix and matching different denominators. So the last one would be, very good. Okay, you can do it? All right, very good. Go ahead and turn to the very last page, please. Okay, we're gonna do one example from the next section. Let's do number 20. Okay, number 20. First thing, what do you imagine I ought to do? Add the root 2, very good. So when I add that to 0, it's just gonna be a root 2. So I have 2 sine 3 theta minus 9 equals root 2. Okay, take a guess. What's my next step? Very good, divide by 2. So then I have sine 3 theta minus 9 equals root 2 over 2. Okay, from here, I get to sine or cosine. That's where I transition to my circle. Okay, but if I want sine, am I looking for this number as an X or Y? Y. You should find 2 spots on your circle. This page, if you look at the instructions, is in degrees. So where do I see root 2 over 2 for the first time as a Y value? Okay, 45. So I'm gonna put 3 theta minus 9 equals 45. And then can you tell me the other spot? There should only be one more. 135 is correct. Very good. So 3 theta minus 9 equals 135. Okay, once we break that up into 2 little baby equations, we're gonna solve both of them, but we're gonna do it the same way. So what should I do first to get rid of this 3 in the front? Divide by 3. Let's do the 45 equation first. What is 45 divided by 3? It is 15. Very good. So I have theta minus 9 equals 15. Last step. Add the 9. And 15 plus 9 means my first theta is 24 degrees. Very good. Okay, now let's work down our second equation. Steps are the same. To get rid of the 3 from the front, I'm going to do what? Divide the 3. So I have theta minus 9 equals 135 divided by 3 is what? Very good. And then to get rid of the minus 9, what do I do? 45 plus 9 gives me 54. Now, these are the correct values, but you're instructed to find a complete solution. And so if you remember what we talked about, sine and cosine do the little wavy thing for forever that they're gonna hit this same solution over and over and over again. So normally we add 360n because 360 is how long it takes the regular sine and cosine graphs to repeat. Will 360 still be the period for number 20?
No.
What number changes the period in the original equation? Very good. And if they put it times 3, what do we do to the period? Divide. So your original period is 360. We're gonna divide that by 3. What is the new period? 120. Very good. So you would come down here and put plus 120n plus 120n. Okay. Then if you were to go back and look at, there's a question where it asks about horizontal stretch or compression. would that be a horizontal stretch or a compression?
Compression.
Cause your original period was 360, and then when you divide it by 3, you made it only 120 degrees, so that'd be a compression. Y'all have any questions? Okay, real quick, I saw some kids in the other class doing number 21 wrong. When you get to the third, how do you undo that? Do you divide by 3 to get rid of the third? No, so when you get to the third, the way you get rid of the divide by 3 is a times by 3 on both sides. Okay, you have the rest of the class to work.
Okay.
Okay, yep. You may just take the test.
Wait, so we did test next class.
Yes.
We
But-
did This. Freeze the review.